Ladies and gentlemen, my name is Alexander Wiechert. I'm the CEO of Vexcel Imaging. I would like to give you a brief introduction into our company and our product portfolio. Vexel is a leader in the geospatial industry. Our product portfolio consists of the UltraCam cameras, the well-known family of cameras serving a wide range of applications from city modeling to photogrammetric applications to wide area high altitude mapping. In addition to the UltraCams, we have our processing software called Ultramap, which gives you a complete suite of photogrammetric processing capability from the raw imagery to ortho imagery to 3D tints. And in addition, in some parts of this world, we have the Vexel data program where we are collecting aerial imagery, let it be in disaster or regular aerial survey for industries like large IT accounts or the insurance industry. With UltraCam, we talk about camera generations. It all started with the first generation in 2003. At that time, we announced the UltraCam D. That camera system was already a very highly successful camera system, and a few years later, 2006, with a facelift in 2008, we announced the next generation, the second camera generation, the UltraCam X, the UltraCam X Prime, the UltraCam X Prime wide angle. Then next in line was the third camera generation. This is where we moved to the birds of prey with a completely new revolutionary system concept, system design. That camera family was introduced in 2011, and since then we had several iterations, several facelifts, and the third camera generation consisted of the UltraCam Eagle as a photogrammetric camera, the UltraCam Osprey for the city mapping with the oblique cones, and the UltraCam Condor, which we designed for wide area mapping. We are now launching our fourth camera generation. That started about 2 years ago, where we introduced the UltraCam Osprey 4.1. Last year at Intergeo we introduced the UltraCam Condor 4.1, and then towards the end of this year again at Intergeo we will launch the Eagle 4.1. That new camera generation, this fourth camera generation, has a kind of a underlying set of common technologies and feature, and based on this new set of technology we have spun off these individual camera models. So let me now first introduce you this kind of common camera architecture of the fourth camera generation. So the key change, the key modification, the key new element is that all these cameras are CMOS based. So we are moving all imaging sensors from the former CCD world into the CMOS world. That has some advantages which we are now leveraging as the CMOS technology is mature enough to be successfully used in aerial imagery collection. Together with the new sensors, all the electronics are new, and thanks to the higher resolution of the sensor we are getting more resolutions, more pixels for an increased flying efficiency, but that also requires to develop new lenses so that these lens systems can fully resolve the higher resolution which we are getting from the CMOS sensor. So all the fourth camera generation cameras have new developed lenses. As a result, we are getting higher image dynamic and higher image resolution, and we are maintaining or even increasing the sharpness and the contrast of the imagery. The new technology gives us also a faster frame rate, so the cameras are capable to collect a picture every 0.7 seconds. That allows to fly either faster and maintain the forward overlap, or with the same flight speed fly a higher forward overlap than with the previous cameras. Thanks to the higher pixel count on the CMOS sensors, the strip width of the camera is bigger, so the collection efficiency increased compared to the former third camera generation. And then in addition, we modified the housing, so the cameras are easier to install, less weight, less power consumptions. We have developed new solid state drives with larger storage capacity, hot swappable of course like before. So we worked on a lot of details to further improve the usability of the UltraCams. A lot changed in the cameras, but also we take care about the existing environment. So the cameras do come with the Ultramap system, which is an integrated GPS, INS, FMS system, but also external GPS INS system like an Aplanix Postrack or an IGI CCNS could be attached like before. So you can reuse the environment which you are already using for the second or third camera generation. The same is true for the mount, so the fourth camera generation is compatible to the Ultramount 3000 and Ultramount 4000. So also here you can reuse what's already installed in your plane. And then of course, and super important nowadays, the cameras are fully integrated in our processing software in Ultramap, so we can consistently process the data regardless from which UltraCam camera generation the data comes. A very specific and new feature we are especially proud about is the so-called adaptive motion compensation. A significant, well, let's say the downside of the CMOS sensor is that there is no embedded forward motion compensation on the sensor like it was in the CCD world. The CCDs had the so-called time-delayed integration, so the charge moved along with the sensor during the exposure time, and that was an embedded integrated forward motion compensation on the sensor. That's not existing on the CMOS technology currently, and so a solution is required to deal with motion compensation. There are mechanical solutions existing. We are thinking in another way, and we have developed another solution that is a software-based solution called adaptive motion compensation, where the motion blur is later compensated in a highly complex software algorithm. And the benefit of this solution is that it is not only capable of correcting forward motion compensation along one direction, like the forward direction, it can also compensate the image blur resulting from multi-angular movement of the camera. So let it be roll, let it be pitch, regardless what kind of motion you have in the picture, the adaptive motion compensation will compensate for it. That is a huge advantage if you need to fly in certain rough conditions where you are still a kind of a roll component, for example, in your blur, or especially also when you fly an oblique camera over cities. The oblique cones are very prone to high motion blur thanks to roll angles, and the adaptive motion compensation compensates perfectly for that. That is a software-based solution exclusively developed by Vexel and will be integrated in all fourth camera generations. So in these examples you see the same imagery. The imagery was taken during a rough flight over London, heavy windy flight, and when you look on the imagery without any motion compensation, it looks quite blurry, and you can also identify several angles of blur. So it's not only due to the forward flight, it is mainly because of roll angle, where the oblique cones are very critical with respect to blur. And then when we switch on the adaptive motion compensation, this image blur is perfectly compensated. Here's another example. Also, please have a look on the fine structures on the facades or the leaves of the trees, and you see a huge difference between adaptive motion compensation off and on. What I just have presented are common features of the fourth camera generation, which we will find in all the different models. Now let's take a few minutes and let's talk about the individual cameras which are based on the fourth camera generation. The first camera system we moved from the third to the fourth camera generation is the UltraCam Osprey, which is now called UltraCam Osprey 4.1. And that camera was introduced at Intergeo 2 years ago. So that is now our oblique camera system, fully CMOS based in high resolution. The camera has an impressive footprint of 20,000 pixels across the flight strip in nadir and additional 150 megapixels in all the oblique cones for the color capture. So the camera concept remained, so it is a photogrammetric camera in the nadir part collecting high resolution pan, RGB and near infrared. That means you can perfectly serve all photogrammetric applications, and then it has RGB forward, backward, left and right looking oblique cones. So it's a kind of two-in-one camera system. The next camera system based on the fourth camera generation is the UltraCam Condor. We announced this camera at Intergeo last year, just a few months ago. That is our high altitude wide area mapping system, which now comes in an impressive footprint of 48,000 pixels across the flight strip. And this camera is specifically designed to collect ortho imagery over really large areas. So when your job is to map a region, a state, a country, a continent, then the UltraCam Condor is the camera to go with. It's collecting high resolution RGB with 48,000 pixels across the flight strip flying efficiency, but then it has a pan channel which is defined in a way so that through this pan channel in a photogrammetric workflow you can generate your surface model, your terrain model, so that you then later can generate your ortho imagery, all based on that one UltraCam flight. So there is no additional LiDAR collection required if you use the UltraCam Condor. And also the camera has a near infrared cone, so that it also supports classification, like lab classification, for example. The camera by itself is designed to be operated at higher altitudes and at a high fly speed, so it's typically flown in turboprops or even jets. Last but not least is the UltraCam Eagle. The plan is to launch this camera as the Eagle 4.1 towards the end of this year, and that will be the last model from our 3 cameras which round up our camera portfolio. And the UltraCam Eagle 4.1 represents again the flagship of the industry, fully CMOS based, high flying efficiency of more than 28,000 pixels across the flight strip, super fast 0.7 seconds frame rate. So please have a look and watch out for this fantastic camera, and I really do hope that we will all see us at Intergeo towards autumn of this year, and you can join us when we are announcing this flagship of the photogrammetric camera systems. Nowadays, hardware is nothing without software. The processing software plays a dominant role in today's aerial solutions, and Ultramap is a powerful software suite which gives you all the tools you need to process the UltraCam imagery in an absolutely efficient and highly automated way. Ultramap consists of several modules. The first module in the processing chain is what we call Ultramap Essentials. That is the module which is required to process the aerial imagery from a raw format into a standardized format, and in this module also all the calibrations like the geometric calibration or the radiometric calibrations are applied. After Ultramap Essentials, the next step would be Ultramap AT. Here all the tasks around the aero triangulations are done again in an automated way, but also very interactive and with a graphical user interface to guide the user and to achieve best-in-class results in the shortest possible time. Once these tasks have been done, The next step would be to start the Ultramap dense matcher. Here in a photogrammetric algorithm, dense matching is being performed. So from the overlaid imagery, a point cloud is being generated, and from that point cloud, it's a kind of a point cloud which I used from LiDAR scanning, but then the point clouds are filtered into a surface model and into a terrain model. Once these data sets have been generated, the next step in the workflow would be the Ultramap ortho pipeline, and here the data sets like the terrain model or the surface model are overlaid with the imagery, and as a result you have either the true ortho image, or how we call it, DFM ortho, or you have the classical ortho imagery, or how we call it, DTM ortho, because it has been rectified with the DTM. And then, last but not least, the last processing step in Ultramap would be the Ultramap 3D tin module, where we are extracting a mesh out of the surface models, so that you have a vectorized mesh which you then can use in downstream applications, for example to vectorize it, to classify, to extract objects, and so on. That workflow is consistent for all the UltraCam models, so it doesn't matter if you fly a second generation camera, a third camera generation, or if you own the latest camera generation. It is an absolutely consistent workflow dealing with all the different data from the UltraCam generations. Last but not least, at the very beginning I was talking about our Vexel data program. I will just briefly talk about this now here. So in the Vexel data program we have two elements. It all started with area imagery capture for disaster areas. So when we launched that program in 2018, we were collecting disaster data. The planes went into the air and were collecting imagery after hurricanes, for example, Michael, Harvey. These have been the first hurricanes where we collected area imagery in record time immediately after the disaster, and then the data was processed overnight and went online the next day, so that the first aiders, NOAA, FEMA, Red Cross and so on, could work with the data and help saving the people on the ground and rebuilding the infrastructure. That's what we are still doing in several parts of this world, and what we were adding over time is that we have what we call blue sky collection. This is where we regularly collect data over cities and also nationwide imagery, which is then delivered to large customers. This brings me to the end of this video. I do hope that you found it worthwhile to listen. I would like to thank you very much for your attention. I wish you a great time. Please take care, stay healthy. I really do hope to be able to see you all in person soon again. And in the meantime, bye bye, take care, and stay healthy.